Hello guys and welcome. I am Ahmed Adel and this is Cost Engineering Professional, and in this video we'll be talking about critical path method with a numerical example. If this is your first time visiting our channel, please consider subscribing and turning on notification because we release regular content related to cost engineering in general. So if this is something that is interesting for you, please make sure to subscribe so that you can benefit from this useful content. And with this, let's get into the video. Alright guys, welcome back. Now in this example, what do we need to discuss? We have a project here, and this project consists of several activities as we can see here, A, B, C, D, and so on. And for each of these activities, we have the predecessor, and we have the successor, and we have the duration. By the way, if you don't know what a predecessor is, what a successor is, I recommend you to click the card in the top right corner, which is a link to our previous video where we have explained all these things in details. So I recommend you to watch that video before you watch the numerical example, and I'll also leave the link to that video in the description. So now I'm assuming that you know what predecessor is and what the successor is. These are just the activities before the activity that we are talking about and the activities after the activity we are talking about. So that's a predecessor and successor. So for each of these activities, what is the predecessor and what is the successor and what is the duration? So these are the data that we have about these activities. So what do we need to calculate now? We need to calculate the project duration, and we need to see what are the critical activities and what is the critical path. So this is what we are going to be doing right now. So the first step here is to put the activity duration and relationships before we start. And how to do that? We have discussed this in the last video. Again, the link in the description if you want to refer to that video. For the activity A, which is the first activity, we will just draw this. We need here to put the early start, early finish, late start, late finish, and the float. And these are the numbers that we are going to be calculating right now. So the first activity here, which is activity A, has no predecessor. There is nothing before A because the project is starting from activity A. And the successor of activity A is activity B. So the activity that will come after A is activity B. And the duration of activity A is 2 days. So all I have to do is to just put A here and put the duration 2. Now let's go to the second activity, which is activity B. For activity B, the predecessor is A. So this is B, and before B we have A, and the successor is C, D, and E. So I have 3 activities here that will come after activity B, which are C and D and E. And the duration of activity B from here, that's 3 days. So we just put activity B with the duration and these 3 arrows for C, D, and E. Now let's put C, D, and E, and the duration is 3, 4, and 7. So C, D, E, 3, 4, 7. And the predecessor of C, D, and E is activity B, as we can see here, because B is coming before them. And for C, we have F as a successor. For D, we also have F as a successor. And for E, we have G as a successor. So how to do that? As we said here, C and D will have F after them. So for F, the predecessor is C and D. So I am putting F here from C, and from D, I'll start F. And for activity G, the predecessor is E. And again, we'll put the duration. For F, we have 5 days, and for G, we have 7 days. So this is what we have done so far. Now, after F, actually here F and G, so after that we have activity H. Activity H has predecessor F and G. Both these activities will lead to the next activity, which is activity H. So if I go ahead and I put activity H here, the duration of activity H is 2 days, and the predecessors of H, I have F and G, as we can see. And what are the successors of activity H? I have activity I and activity J. So I'll have 2 activities here, I and J. For I and j, what is the duration? We have duration of 4 days and we have a duration of 5 days. So we will put the durations here. And for activity I, the predecessor is h. For I, the predecessor is h. And for j as well, the predecessor is h. And then I have activity k, which has I and j as predecessors. So I'll put activity k here with the duration 4 days. And the predecessors of k are I and j. And there is no any successor because this is the last activity in the project. So now I have created this. And I know that which activity is coming after which activity and what are the relationships. So we have the predecessor and the successor and the duration for each of our project activities. Now, I need to do something that is called the forward pass. And from the forward pass, what I'm going to be calculating, I'm going to calculate the project duration, and I'm going to calculate the early start and early finish for each of these activities. So let's start now. I'll start here from 0. And actually you can also start with 1, but I'll have a special video talking about the difference between starting here the project with 0 or starting with 1. So for the purpose of this example, we are going to be starting with 0. So this is the early start of activity A, because now I have this now. All I have to do now is to calculate the early start and the early finish and the project duration for these activities. So I'll start from 0, and for activity A, I have the duration here, 2. So I'll just say 0 plus 2 equal to 2. So early start is 0, early finish is 2. So just early start plus duration will give me the early finish. Okay, next. 2, which is the early finish here, will come as the early start here for the next activity. So this 2 will come here. Okay, and the duration of activity B is 3 days. So again, 2 plus 3, that's 5. Okay, so this is the early finish here. It will go as the early start of these 3 activities because these 3 activities are coming after activity B. So the 5 will go here and here and here. Again, 5 plus 3, that's 8. 5 plus 4, that's 9. 5 plus 7, that's 12. Okay, very good. So until here, I think it's very straightforward. There is nothing hard. I'm just 0 plus 2 equal 2. The 2 will come here, plus 3, that's 5. The 5 will go in these 3 locations. Then 5 plus 3, 5 plus 4, 5 plus 7. Now, in order for activity F to start, I have to finish both activities, C and D. And this is we got from here. F has predecessors C and D, and you can see the arrows. So in order for F to start, C has to finish and D also has to finish. So if C is going to finish on day 8, if C is going to finish at day 8 and D is going to finish at day 9, F can start only after D is finished because D is the latest. This one will finish first, then D will finish, but F needs both to be completed before it can start. So F will start on 8 or 9. Logically, it should start on 9 because on 8, this activity is completed, but this activity is not completed. So I have to wait anyway until 9 so that D also is completed so that F can start. So even though the start of F depends on the end of both C and D, I have to wait until D is finished so that I have both of them finished so that F can start. So what should come here? Is it 8 or 9? It is 9. So the 9, because it is the latest, will come here. And because G is depending only on E, so that's the 12 will come here. Similar, the 5 came everywhere, or the 2 came here. This 5 will go here. So the 12 will just go here because it is just one arrow. G is depending only on E. So once E is completed on 12, G can start on 12. But here, F has to start after the latest, after D. So it will start on 9. And again, 9 plus 5, that's 14. And 12 plus 7, that's 19. Again, similar case. H start is depending that F and G should be completed, both of them. F will finish on 14 and G will finish on 19. So anyway, after F is completed, H cannot start unless G is also completed, and G will be completed by 19. So the 19 or the 14 will come here. Logically, the 19 should come here so that H can start after both of them are completed, because H is depending on both of them. The predecessors of H are both F and G, both of them. Okay? So when the 19 goes here, again, 19 plus 2, that's 21. And as we said, when it is like that, the start of I and the start of J is depending on the completion or end of H. So because H will finish on 21, so both I and J can start also on 21. So the 21 will go here and the 21 will go here. So again, 21 plus 4, that's 25. 21 plus 5, that's 26. Again, K can start only after I and J, both of them are completed. So this will finish on 25 and this will finish on 26. So K can start after both of them are finished. Both of them will be finished at the same time on 26. So the 26 is the number that will come here. And again, 26 plus 4, that's 30. So from what we have done so far, from the forward pass, what can we understand or what can we calculate? We have calculated the early start and the early finish for all the activities, as you can see. And we have also calculated the project duration. So the duration of this project is 30. And that's why we use the CPM, because when I give you this table, I am telling you that you have a project that consists of these activities, and these are the predecessors, these are the successors, and this is the duration of each activity. What is the duration of the project? You can know or you can calculate the duration of the project only when you do the CPM and you do the forward pass. So here you see that activity K will end on 30, and this is the end of the project, or this is the duration of the project. Good. So far we have early start, early finish, and we have the project duration. Now let's do something that is called the backward pass. And in the backward pass, we will calculate the late start and the late finish, and we will calculate the float. Again, as I told you, all these terminologies were explained in details in our previous video. You can find the link in the description and go watch that to know all these things. Then you can come back and watch this video for the numbers. And please, if you are liking this video so far, please give it a thumbs up, subscribe, share, show us love, guys. We love talking to you always. Comment on the video even so that we can reply to you. Okay, let's continue with the backward pass. So the early start and the early finish of activity K are 26 and 30. So I knew that, or I calculated that the project duration is 30 days. So anyway, it doesn't matter what happens in between, I have to finish the project by 30. So the late finish of the last activity must be equal to the early finish. So I have to finish this project by 30 or on 30 days. So anyway, the late finish will be 30 days. Very good. So if this is the late finish, what is the early finish? Late finish minus the duration. It will give the late start. So late finish minus duration, it will give me the late start. So again, it's similar to what I was doing here. I was telling 26 plus 4 equal 30. So 30 minus 4, that's 26. But since I understand that for the last activity, the project duration is 30, so the last activity on the early side or on the late side, it has to finish by 30. So the late finish is the same number, which is 30. And I want the late start, so late finish minus duration, it will give me the late start. Okay. What I can understand here is that activity K will start on 26. So in order for activity K to start, activity I and activity J, both of them need to finish so that activity K can start. So what is the meaning of that? It means that maximum by maximum 26 here and here, I have to finish these two activities by maximum 26, which is the late finish, so that activity K can start, because the late start here is 26. So the 26 will come here and here because both of them must be finished by maximum 26 in order for activity K to start on 26. And again, when I bring the 26 here and here, I'll just say 26 minus the duration. It will give me this is the late finish now. Late finish minus duration will give me the late start. So 26 minus 5, that's 21. And 26 minus 4, that's 22. So there is a number here, which is the float, as we discussed last time. And what is the float? The float is the time, or here, what we are seeing here is the total float. The total float is the number of days that this activity can delay without delaying the project. And as we said, if the float is 0, that means that this activity is critical, and we are coming to that in a moment. But how to calculate the float? The float is equal to late finish minus early finish, or late start minus early start. So 26 minus 25, that's 1. And 22 minus 21, that's also 1. So I have 1 day that I can delay here. Okay? And for this one, 26 minus 26, that's 0. 21 minus 21, that's also 0. And what is the meaning of that? Actually, the early finish here is 25, and the early finish here is 26. But activity K can start only after activity I and activity J. Both of them are completed. So both of them will be completed only by 26, because this will finish at 25, but activity K need activity J also to be completed in order for activity K to start. So I need to start here at 26 anyway. So this activity I, the early finish here is 25, but it doesn't matter if it got delayed by 1 day and finished on 26, because in that case both of them will be completed by 26, so K can start without any delay. So nothing will happen if this activity I is delayed by 1 day. Why? Because the early finish is 25 and the late finish is 26. How did we know that the late finish is 26 here? Because the early start here is the late start is 26. So as we said, the 26 will come here and it will come here. And when you say late minus early, either for the finish or for the start, it will give you the float. So 26 minus 25, that's 1. 22 minus 21, that's also 1. Very good. Now, the next part is, what about activity H? Here, we have calculated the late start for activity I and for activity J. The late start here is 22 and the late start here is 21. So when I have this case, this activity can start on 22 and this activity can start on 21. But actually, the start of these two activities is depending on the completion of H. So I know that activity J must maximum start on 21 and activity I can maximum start on 22. So if for activity H is completed at 22, this activity will be delayed because the latest start here, the maximum date that you can start this activity without delaying the project is 21. So what if this activity finished on 22? Then this will start on 22. It means I have delayed the project. Instead of 30 days, it will be 31 days. So when I am doing the backward pass, whenever I encounter this case that I have two activities here and I want to calculate the late start and the late finish for one activity, usually I take here the minimum of this and this. So in that case, the minimum is 21. And what is the explanation? It's what I told you now, because if I take the 22 and put it here, then this activity, it should start as an early start and as a late start at 21. So if this ends at 22, then this is a problem because this activity cannot start. It will start only on 22 and it will delay the project. Okay, let's continue. Now we have activity F and activity G. So since I have 19 here, the 19 will come here and here because it is only one number. The 19 will come as late start will come here as a late finish and here as a late finish. And again, I'll say if I want to calculate the float, late minus early or late minus early. So 19 minus 14, that's 5. Or 14 minus 9, that's also 5. And how do I get the 14 even? Again, the finish minus the duration, it will give you the start. So the late start here is the late finish, which is the 19 coming from here. 19 minus 5, that's 14. And 19 minus 7, that's 12. Okay, again we have the same case that we have activity F, and the successors of activity F are C and D. So in that case, the 14, which is here, will come here, and the 12, which is here, will go here. Okay, this is the late start, so this late start will come here as a late finish, and here the late start will come here and here as a late finish. So again, 14 minus 9, that's 5. 14 minus 8, that's 6. And if I say, if I want to calculate the late start, again 14 minus the duration, it's 11. 14 minus 4, that's 10. 12 minus 7, that's 5, to calculate these three numbers. And the float is always this minus this, or this minus this. But how do I get this one? This one is the late finish minus the duration. Okay, now let's go to activity B. This is a very important point now. Activity C, the late start is 11. Activity D, the late start is 10. Activity E, the late start is 5. And these three activities can start only when activity B is completed. So if I take the 11 here, if I say that, okay, for me no problem that activity B can end on 11. If activity B ends on 11, then activity E will start also on 11, because I need activity B to finish in order for these three activities to start. So I cannot do that. I cannot take the 11 here. I cannot take the 10 here. As we said, we take the minimum. Activity B must finish on 5, because if it finished after 5, it will delay activity E, which will delay activity G, which will delay activity H, which will delay activity J, which will delay the project. Okay, so here the 5 will come here, and I'll say 5 minus 3, that's 2. 5 minus 5, 0, or 2 minus 2, that's 0. And the 2 again will come here. 2 minus 2, that's 0, or 0 minus 0, that's 0. And here, in order to calculate the late start, I'll say the late finish minus the duration, that's the late start. So now I have got all the items. What can we understand from this example is that activity A can finish only on second, or on 2, day number 2, or whatever, number 2 here. Why? Because if it finished on day number 3, then the 3 will come here. The 2 becomes 3, so 3 plus 3, that's 6. Then here I'll put, instead of 5, I'll put 6, and so on. So I am delaying everything by 1 day. So I always look here to the float, and the activities where the float is 0, it means you cannot delay these activities by even 1 second. Because if you delay any of these activities, you are delaying the completion of the project. You are delaying the project, because these activities are critical. We have discussed what is a critical activity and what is the critical path. So we can see here, as you can see, this is what we have done so far. So we can understand that the critical path, and as we said, the critical path is a sequence of activities. This is the longest sequence of these activities that cannot be delayed at all, because if any of the activities on this sequence are delayed, it will delay the end of the project. And the activities on the critical path are critical activities because they are critical. If they are delayed, they will delay the end of the project, and that's why the float here is, as you can see, 0. So this is what we get from doing the CPM. So the project duration here you can see is 30 days, because we have calculated that in the forward pass, and we have calculated also the early start and the early finish in the forward pass. And in the backward pass, what we have calculated the late finish and the late start and the float. And we understood now what are these things. So the critical path here in this project is A, B, E, G, H, J, K. Any activity that is falling on this path cannot be delayed by even 1 minute, because if it happens, the project also will be delayed by 1 minute or 1 day or whatever delay that happens, because these activities have no float in them. Actually, in the next video, guys, I'll explain to you what if I start here from 1. The project duration will be similar, like still, because starting from 0 or starting from 1 is just a method of calculation, but it shouldn't change the end result. I'll start here from 1 and it will end at 30 days. This is what I'm going to be showing you in the next video. Anyway, it will end at 30 because having these activities, having these relationships, having these durations, and using the critical path method, that the duration of this project is 30 days. And this is where the Primavera actually comes in use. Like, how many activities we have here? 5, 7, 8, 10, 11 activities, and you see we have been talking now for so long to do the scheduling for these activities and to know which of them are critical and which of them are not critical, and what is the critical path, what is the project duration. So for 11 activities, it took us this long to talk about it or to calculate it. Imagine if you have a project of 100 activities or 500 activities or 1000 activities. Do you think that you can do this manually just as we did it right now? It cannot be. That's why we have planning and scheduling softwares like MS Project and the Primavera and all these programs, and these programs are working with CPM or critical path method. But the thing is that the tool or the software will help you to keep all these data organized, and it will calculate for you the duration, and it will calculate for you the float and everything in each activity, and it will tell you what is the critical path and all these things in a very organized manner. If you guys have enjoyed this video, thank you so much for being here with me watching, and I appreciate your valued time watching this content. Please like, subscribe, and turn on notification. Even please comment on the video because I love talking to you guys. And I would like just to make a small notification here about our online courses. You can find our quantity surveying course and cost estimation course and procurement course in the description. You might have a look at them as well if you are interested. And with this, please stay safe and take care of your families, and I'll see you in the next video. Bye bye.